Hello everyone, and thanks again for tuning in. In this video, I guess we'd just like to go a little bit more in detail in how we modify the altimeter. So one of the first things that you may think about is whether you want to stimulate it or simulate it. So if you go with stimulating it, you would leave the original altimeter as is. And these were the electronics that were inside the original altimeter. The driver circuit, they had a synchro, and focus this here. Let's see if it focuses. It had a synchro resolver, and this synchro resolver was driving the main shaft. It was located here, driving the main shaft. Also, they had a DC 28 volt motor, and that was basically driving the this shaft over here, this guy. So if you go that route, then you would use a synchro transmitter, which would be this guy here. The synchro transmitter, and basically you would have the Arduino through your driver circuit, your driver board, command the stepper motor, and you would put two gears on these guys, and as this stepper motor drives his shaft, his output signal will automatically drive this resolver. So we went over that method with the ADI and HSI. It would have been the same concept, using stepper motors to drive a synchro motor. So for this particular one, instead of stimulating it, we went with simulating it. So we took out those pieces and we put in our own stepper motor driver board, located that inside, and we used a proximity switch mounted inside. And if we turn this on its side here, you can kind of see it there. And if we focus in on it, so if we turn this main gear, you can see the proximity light go on and off. So basically we just drilled a small hole. It's not that large slot, but it's a little hole on the edge of the gear here. So as that passes through the proximity switch, you'll see it activate and deactivate. So even though we mounted that proximity switch, we ended up not using it in software. We just went with the OEM's 10-turn pot here. So that's what we're using to home the stepper motor. But just a good idea to have the proximity switch as a backup, just in case that AI signal was too noisy or something. But as you can see, as you turn the gears, the pot shaft turns as well. So, you know, that's why we were covered there. So, had the proximity switch, we mounted an encoder, this guy, and it watches the borrow pressure knob, and we just mounted him to the back there, and it's tied to this shaft so that if you turn this knob, the encoder monitors that. So that's what that does for us. So, and that's the borrow in the front there. Okay, so we did that. As far as the lighting goes, the altimeter comes with the regular incandescent lamps, and you can kind of see the light bus up top. But as you know, the A-10 uses Invis green, so we just got an LED strip here, basically, and we just cut the ends of it off and mounted them in the opposite corners. This one here is in this top corner, and there's another in the bottom right corner that's done the exact same way. So when you cut these off, we're leaving out the resistor. So that's why in these assortment of resistors here, we have to replace that, and we just located them in this wire bundle here. But those are our 2 resistors, one for each LED light. So we did that. In previous videos, we talked about that transistor before, same type circuit where we use a transistor to drive a particular motor, or in this case, it's the on-off flag, this guy here, and this decision height light. But we went over that circuit before, and it's the same one. So it's good to have little printed circuit board pieces laying around to mount your components. What else we used? Of course, we've used a L298N stepper driver board, and we located that there. Helpful to have a Dremel tool, various metal cutting attachments. This one here is to smooth out the rough edges after you cut the metal, but that comes in handy. Like, for example, cutting out the opening for the when I mounted all these components. 3D printer comes in helpful as well. You can print out your back plate, various support brackets, things like that. That driver board is held on by another 3D printed plate at the bottom. So definitely recommend that. I'm using a TAS5 by Luzbot 3D printer. So whatever you use, definitely would recommend having a 3D printer. Let's see, what else did we use here? Let's see. I guess I can talk a little bit about the earlier renditions of this mod. At one point I did have a stepper motor here, just printed out a little custom bracket, and I held it at the top here to drive this particular gear. But I don't have a machine shop, and any misalignment of the gears ain't perfectly straight. That'll cause too much friction, so it wasn't strong enough to drive that main gear. So that's why I went with a bigger motor, this guy here. And he has enough torque to, even though it's not like a perfect alignment, he has enough torque to drive that main gear. So 3D printed another little adapter piece to connect the shafts together. And when I mounted that motor, the weight of the motor back here causes the whole thing to causes the shaft to want to tilt up. So it would not want to rest on the gears at the bottom here. So I just printed another 3D, like a little hook bracket. And so I just pressed down on it and super glued it to this plate so that hook constantly presses down to keep the gears meshed together. And the other thing that I didn't notice until everything was put together, the resolution of this guy, I think it's about 2 degrees per step. But he has a large shaft, which is this wheel, and he's turning a small shaft. You might can see him at the bottom there. Maybe, maybe not. But it's that gear at the bottom. So that really hurts your resolution, because you got the motor on the big gear turning the small gear. So any little movement here turns this guy a lot. So the resolution of this motor is only about 20 feet. So at every 20 feet is the resolution in this current configuration. So I may go back to using this small motor, putting them over to the right and having him drive this gear over on the right side. And that's one of the renditions I had, was using this gear here. And since this is a smaller gear driving a fairly larger gear, that one, your resolution is about a 1/2 foot increments, which was much better. So I guess we'll just go ahead and demo that without further ado. We got the sim up and running. So I'm gonna go ahead and load that on. I'll turn on our power supply. As soon as he turns on, he's gonna automatically align with the sim meter. So we'll turn on the COM port. So he's going to count down to 0 and initialize. So he'll find a spot and then he'll initialize after that. Okay, so that's where we're at. We're on the tarmac here, and if I zoom in on the altimeter real quick. Let's see, like for example, if you turn your borrow knob here to like 3000, you'll see that one go as well. I'm gonna keep turning. Like maybe to 315, and that's 315. Still need to add the software so that when I turn the pressure settings, that the altimeter, you'll see this needle move. Need to still add the software portion to that, but we'll do that later. Okay, so we'll go ahead and let me lighten the load here. I like to see the stick. Okay, so need to trim this out. So let's go ahead. And what I'm doing is for the Thrustmaster, I'm using this as my rudder to try to steer the plane, which reminds me I need to turn off the nose wheel steering. And we'll just give it some throttle, grab the stick over here. I'll give it some rudder. Keep on the runway. Okay. Which way are we going here? Alright, so trying to pick up some speed. Alright, I guess we're fast enough to rotate. We'll go ahead and pull back. Let's see the altimeter. Let's go ahead and raise our gear. Put up our flaps. Okay, so I reckon using the picture. Now what we're looking at is the raw altitude is just altitude mean feet above sea level, and the target altitude is actually what the stepper motor is using. So the minus sign is just direction. Doesn't it just means clockwise or counterclockwise, and the number behind the minus sign is just a scaling factor. What the altimeter is calculating for to generate the right reading on the instrument. So that's just a scaling number. So as far as the steps go, you can kind of see what I'm talking about. It'll gotta nose down a little bit. It'll increment about every 20 feet is the resolution. So that's kinda okay. I might, like I say, rearrange that so that the resolution to probably be around about every 1 foot or a half foot. The only downside was the smaller motor and running that smaller gear. The altitude, I can probably get it to about 7,000 or 8,000 feet per minute. But if you're descending faster than that, it'll probably outrun the instrument. But I think 7,000 to 8,000 feet per minute is sufficient. The A-10 isn't all that fast, even in a nosedive. You'll probably be around about maybe 9,000 feet per minute. And even then, you probably have to climb to a high altitude to achieve that. And also, if we cut off the power here, we'll go ahead and do that. If we turn off all the electrical buses anyway, the altimeter goes off. And if we turn power back on, well, at least one bus anyway, it'll revive. So that's pretty much it. So if you're looking to modify that, some things to keep in mind is the resolution of your motor. Here we kind of used the setup that was already there in place, but if you do that, then you want a motor this one here's about 2 degrees per step. You probably want something that's 1 to maybe 1/2 degree per step in order to get a better resolution. But it looks cool in the nosedive though. We'll go ahead and do that. Show what I'm talking about. So we're about at 10,000 feet. And we'll go ahead and nosedive. And we'll try to pull up here. We hit the ground. That's it. So, that's basically it. So at any rate, that's probably all what's involved in modifying your altimeter. I don't know if I mentioned it before, but I got a bag of miscellaneous stuff, screws and gears from taking other instruments apart. Grab this real quick.
Altitude.
Oh well. And so stuff like that comes in handy. Dremel tools. Like I say, 3D printer, those probably the other 2 major pieces. Definitely don't want to be at a negative altitude, that's for sure. And that's pretty much it. And once again, thanks for watching and good luck with your cockpits.